In this skill, we're trying to find the center of mass of an object or a system of objects. The center of mass is basically the average location of the mass of an object or a system of objects. And like the fulcrum of a seesaw, it's the point where your system would balance. Another helpful thing to know about the center of mass is that if your object or system of objects is symmetrical at all, the center of mass will lie on the lines of symmetry. So if you imagine a seesaw with no one sitting on it, the center of mass of that seesaw will be the middle, because that's our line of symmetry. That's where our seesaw will balance. Okay, so in this question, we've got two objects, and we're told both objects have the same mass. We need to figure out where is the center of mass. So looking at our system, we've got one object here and one object here. They both have the same mass. So this system is symmetrical because we've just got two objects of the same mass. And this is our line of symmetry for this system, because we've got one mass 3 squares above and one mass 3 squares below. So our center of mass is going to lay along that line. It's also symmetrical along this axis here, because along this axis we've got our masses sitting on the axis. So that tells us our center of mass is going to be at point G. In this question, we again have two objects, but this time the larger object has the larger mass. So we have this larger object on the right, which has a big mass, and a smaller object on the left, which has a smaller mass. So thinking about lines of symmetry, we know we have one line of symmetry horizontally through those two objects, because those objects lay on that line. Now, if these objects had the same mass, we would also have a line of symmetry here, and our center of mass would be point E. However, because the right-hand mass is bigger than the left-hand mass, the center of mass is actually going to be shifted to the right, which means that a point to the right of point E, but still along that first line of symmetry, has to be our center of mass, which means point F is going to be our best guess for our center of mass. In this question, we now have three objects, and they all have the same mass. So let's think about lines of symmetry here. Well, I can see that I've got two objects above, which are on the same horizontal location, and an object below that's directly central between them. So that means that this line is going to be a line of symmetry, because I've got an object on the left that's 3 squares away, and an object on the right that's 3 squares away from my line at the same height. So those are symmetrical. And then our other object is on the line. So that's a line of symmetry. We know that our center of mass is going to lay along that line. What about the center of mass in the vertical direction? At this vertical location, we have one object. And at this vertical location, we have two objects. So my average mass, or my center of mass, is going to be closer to the top towards those two objects than it is to the bottom to that one object, because that's got 2 times the mass at that location compared with this location. So that means that C is going to be my best guess for the center of mass. So C is going to be our answer here. Now in this question, we have a 2D object. We're told the object has a uniform density. So looking at our object, we can see we have a line of symmetry vertically down the middle because we've got the same shape on the left reflected on the right. And we also have a line of symmetry horizontally down the middle because again we have the same shape reflected above as we have below. So that's going to make E our center of mass for this shape. Lastly, we have this shape here, which is again a 2D object. And again, we're told has a uniform density. Now this shape's a little bit more complicated. It doesn't have lines of symmetry that we can use. However, there is a trick we can use for this one. I'm going to split this shape up into two shapes that are the same as each other. So if I put a line here on my diagram, then I end up with a shape here that's 2 squares by 6 squares. And then my other shape here is also 2 squares by 6 squares. So 2 identical shapes with uniform densities. So we know that the center of mass of each of these shapes is going to be in the middle of those shapes. So center of mass of one is going to be shown by that X there. And the center of mass of the other is going to be shown by that X there. So now I know that my big complicated shape just boils down to 2 equal masses at these 2 locations marked with an X. So I know that my center of mass is going to lie directly between these points. And that's going to be at point E. So my tips for finding the center of mass is firstly to look at lines of symmetry. The center of mass always lies along lines of symmetry if they are any. Once you've found your lines of symmetry, if it doesn't get you the answer, your center of mass is going to lie closer to the heavier mass or where more mass is located. And if you have a more complicated shape, you can split up your shape into smaller shapes and then use the center of masses of those shapes to figure out where the center of mass of the overall shape is going to lie.